Electricity usage today is becoming more unpredictable. Homes with solar and batteries often don't know the right time to store energy, use it, or sell it. Most systems charge and discharge blindly without checking live weather, peak grid pricing, or real time home demand. This leads to wasted renewable power, higher bills, and unreliable backup during outages. And that's exactly the problem we are trying to solve. The solution isn't better hardware, it's a smarter software that learns, predicts, and adapts to your home's unique energy rhythm. Smart energy controller that combines live weather forecasting, machine learning, and a reinforcement learning agent to manage a home grid intelligently in real time. Now I'll walk you through how it works. First, I enter my system details. Here I set the size of my solar panels, wind capacity if I have a turbine, and the battery size. This defines the physical limits of the home energy system. So let's I have pre-entered the details. Then the next step is to select your location. Different cities have different solar patterns, temperatures, and wind speed. So the system uses this to fetch accurate live weather data. And when I click on grid plan, the backend pulls 24 hours of weather data and generates a complete energy forecast. This is a 24-hour master plan. Using the weather API and a trend demand forecasting model, the system predicts my energy usage and renewable generation for every hour of the day. At the top, I get key highlights: total renewable generation, total home demand, the hour of peak generation, and the hour of peak consumption. The orange curve shows how much energy the home will consume, and the green curve shows the expected solar or wind generation. You can see solar ramp up in the morning, peak around noon, and drop to zero in the evening. This helps the AI plan when to charge or discharge the battery. And below is the detailed hour by hour breakdown. This forecast becomes the schedule the AI controller uses for decision making. Now let's look at the live dashboard to showcase you the real-time AI decision. First, I need to select my city, or I can just simply use my current location. By that, click on Get Plan, and I will get a live dashboard. Here, the system pulls backend every few seconds and shows the AI decisions in the real time. The banner displays the current action chosen by the reinforcement learning agent. On the left, I see my total renewable generation. In the middle, I see live home demand along with the current grid price period. On the right, I see the battery state of charge constantly updating as the AI charges or discharges it. Important features is the power cut simulation. When I tap simulate power cut, the grid instantly goes offline. The system switches into emergency battery mode and the battery begins powering the home. You can see the state of charge dropping realistically as energy is consumed. Without any grid support, it shows how the controller maintains resilience during outages. Take a look at the AI simulator which we have built to showcase the working and functioning of our AI system. This is the grid main dashboard simulator which we have built to showcase our AI system. Now there are two modes, API monitor and local simulator. Now let's first take a look at the API monitor. This API monitor shows your battery, renewable supply, live demand, and grid price. There are live charts and API full log and history available. So let's start it by clicking on the start button. As you can see, live charts are being generated for demand, solar, and wind. As you can see, the total SOC and the time. I can change the way I can view it. I can full screen the entire chart. or I can see it in tables. If I want to download it, I can download it in the form of an CSV, and wherever I want, I can save it. If I want to search something, I can just search it, type in suppose as solar, and it will highlight it for you. So now let's pause it for a bit. Clicking on the pause button. Now here you can see the entire API code log and history. This is the data which was captured by the API. This is live data which was captured. Here you can see the solar, wind, demand, the price period, then the action. The action, these are which are taken by our AI. Then I can again export this log to a CSV, and it will be get exported. Look at the local simulator mode, which lets me test the smart grid entirely inside the browser without depending on the backend server. This mode is extremely useful for experimentation, debugging, and understanding how the AI behaves under different conditions. Here, I have two agent options. In this simulator, is a random agent and a smart agent, and each has a very specific purpose. Random agent makes completely random decisions. It charges, discharges, buys, or sells energy without any strategy. This might look chaotic, but it's actually very important. It gives me a baseline for comparison by watching an untrained, unintelligent agent operate. I can clearly see what poor decision making looks like: wasted energy, unnecessary battery drain, and frequent unmet demand. It also acts as a stress tester, helping me check how the environment reacts under unpredictable behavior. So, random agent is not meant to be efficient, it's meant to show how bad things can get without intelligence. So, let's run it. And here you can see the behavior of a random agent. The values, these are complete random, they are not live data values. And this is the log. Here you can see it has taken random actions. The profit is negative, there are zero unmet demands. Now, a smart agent, on the other hand, uses the same reinforcement learning model that powers our energy controller. This makes agent more optimized goal-driven decisions. It has been trained inside this simulated environment to minimize unmet demand, preserve battery health, and make intelligent choices about when to buy or sell energy. By comparing the behavior of the smart agent versus the random agent, I can clearly demonstrate how much value AI adds. This contrast is important both for evaluation and for explaining the model's real-world usefulness. But manual controls. These help us in complete experimentation. You can just simply force action, means we can force the AI to take final action. The the best feature of our simulator is that it shows the user what action it needs to take. But when you click on use force action, it forces the AI to directly take the action without consulting with the user. It only happens when our data is exactly correct and when we run it in our API monitor mode, because in API monitor mode, whatever values you are generating, these are real values. And you can drop down on the menu, you can charge a battery, discharge battery, sell to grid, or buy from the grid. These are the actions which you can force the AI to take. And also I can simulate some fault and scenarios where such as scenarios like a solar panel failure for a chosen duration to see how the system behaves and part of the energy source goes offline. This lets me observe how the smart agent responds to unexpected failures, something that's difficult to test in real life. Now let's simulate the solar fault, and the duration we keep it for 10 steps, and I can start and resume it. And here you can see solar power has completely gone to zero. This blue line shows us the solar input, and you can see it has completely gone to value zero. This helps us in simulating unexpected failures. That's the complete system. A full smart energy controller that predicts, plans, and reacts using real weather data, machine learning forecasts, and reinforcement learning intelligence. It can monitor life conditions, simulate scenarios, and even handle emergencies like power cuts. This is where intelligent forecasting meets real-time decision making, turning a simple power grid into a smart adaptive ecosystem. Thank you.